Introduced the law of conservation of energy and kind of how those transformations work, which is using the work energy theorem. This lesson, we're going to do some applying of the law of conservation of energy. Okay, so learning target. I can explain how in any system, the total amount of energy at the beginning is equal to the total amount of energy at the end, even as the energy changes form or location. Okay, so we already went through the law of conservation of energy. I'm going to read it one more time. Energy cannot be created or destroyed, only transformed from one type to another, unless a force from outside of the system acts on it. Okay, it's the what does this mean that's important. So therefore, total amount of energy in a system must stay the same. Okay, so the total amount of energy, no matter what happens within that that change, the amount of energy has to stay the same. Okay, so we have the total amount of energy at the beginning has to equal the total amount of energy at the end. Okay, that's the easy way of stating it. But what does that mean, right? So basically, it's add up all of the energies in the beginning. Okay. Another way of putting that is the sum of E at the start. Okay. And when it says add up all, it means everything: kinetic energy, potential energy, elastic energy, heat, sound, light, anything else that could possibly be an energy at that point. Okay. That's going to equal add up all the energies at the end, right? Or the sum of the energies at the end. Okay. So the best way to understand this is to actually work with it. Okay. So I have a picture, and in that picture, I have a boy, or maybe it's a girl, I don't know, on a skateboard, and he or she is going across the sidewalk until they get to a hill. Okay. And so they're going to keep going at a constant speed until they get to the hill, and then they're going to go up. Okay. So they ask us to find, or they're asking us to find the potential energy, the kinetic energy, and the mechanical energy for each of these situations. So the thing you need to understand is that mechanical energy is the same as saying the total energy in the system. Okay. Just reminding you that gravitational potential energy is mgh. Kinetic energy is 1/2 mv squared. Okay. So at the beginning, we have a 60 kilogram kid. They're moving at a velocity of 8 meters per second. And at the moment, their height is 0. Okay. So looking at our gravitational potential energy, if the height is 0, our potential energy is 0. Okay. Looking at our kinetic energy, 1/2 mass times velocity squared. So 1/2 times 60 times 8 squared. That is 1,920 joules. So if I add my potential and my kinetic energies together, I get my total energy, my mechanical energy. When I do that, 0 plus 1,920 is 1,920 joules. All right, here's the thing. The mechanical energy, the total energy, has to stay the same. So that means that the total energy at point 1 has to be the same as the total energy at point 2. So that means that in our list here, the mechanical energy is 1,920 joules. Okay. In the second picture, you'll notice we have the same kid, still 60 kilograms. Um, the height has changed. They're now 1 meter above the ground. But that's all they give us. Okay. So from there, we need to look at, can we calculate the potential energy? So gravitational potential energy, mass times gravity times height. So 60 times 9.8 times 1 gives me 588. Okay. They don't tell us how fast he's moving. So calculating the kinetic energy this way isn't an option. But we know that the total energy is the potential energy plus the kinetic energy. So if I take the total energy minus the potential energy, the leftover has to be kinetic energy. Okay. So when I subtract 1920 from 588, I get 1,332 joules. Okay. We can also solve for the velocity. So we can also figure out how fast he's going at that point. So looking at our equation, we're going to move it around a little bit. So we're going to take our kinetic energy, we're going to divide it by 1/2 of the mass, and then we're going to take the square root of that answer. Okay. So 1,332 divided by 1/2 of 60. And then we take the square root of that. We get that our velocity is 6.66 meters per second. Okay. Now ask yourself, does it make sense? Well, he started at 8 meters per second. When they get up into the ramp, right? As you go up the ramp, you're going to slow down. Okay. So having the second velocity be less than the first velocity, that makes sense. Okay. Now, most of our questions are not going to be fill in the blank. Okay. Most of them are going to be similar to this like short story type thing. So a 300 kilogram pig is standing at the top of a muddy hill on a rainy day. The gravitational potential energy at the top of the hill is 147,000 joules. The pig slips and slides down the hill. They want to know, what is the kinetic energy of the pig at the bottom of the hill, and what is the pig's speed at the bottom of the hill. Okay, so we're given that the gravitational potential energy is 147,000 joules. Okay, we're given that the mass of the pig is 300 kilograms. We're also given that the kinetic energy at the top of the hill is 0, right? Because he's just sitting there. And then at the bottom of the hill, right, when he gets to the bottom, he has no height. So his gravitational potential energy at the end is 0. We're trying to find the kinetic energy and the velocity of the pig at the bottom of the hill. Okay. So looking at our sum of the energies at the start equals the sum of the energies at the end. The only energies we're concerned with at this point are gravitational potential energy and kinetic energy. So we're going to add the gravitational energy and the kinetic energy at the beginning, same thing at the end, right? All right, so and then we also know that the kinetic energy is 1/2 m times v squared. Okay. All right, so they give us the gravitational potential energy at the beginning, so that's 147,000. They also tell us that the kinetic energy is at the beginning is 0. We know that the gravitational potential energy at the end is 0, and then we're looking for kinetic energy. If we do the math, we get that the kinetic energy is equal to 147,000 joules. Okay, so we've got the first part. The second part is take that kinetic energy, right, and substitute it into the kinetic energy equals 1/2 mv squared. to get V. So I substituted 147,000 equals 1/2 times 300, because the pig does not lose weight as he goes down the hill, um, times V squared. Okay, so if I take 147,000 and I divide by 1/2 of 300, I end up with 980. Okay, so V squared is 980. Um, then take the square root of 980 and you get the velocity is 31.3 meters per second. Okay, he's a big pig, so going down the hill and having that much velocity is a good possibility. Okay, so to sum it up, the law of conservation of energy states that energy cannot be created or destroyed unless only transformed from one type to another, unless a force from outside the system acts on it. Okay, and that the equation for the conservation of energy is the sum of all the energies at the beginning is equal to the sum of all the energies at the end.